Welcome back, everyone. Look, if you're in engineering leadership right now, you already know the daily friction we're all dealing with. We're all trying to move these AI agents from those, frankly, jaw-dropping prototypes into rock-solid production systems. But let's be honest, making that jump is incredibly hard. So today, we're unpacking the Architect's Guide to Agentic Systems in 2026. We're going to dive right in and look at the actual mechanics of what separates a fragile demo from a truly dependable system.
So, why do autonomous agents fail when the stakes are real? It's the million-dollar question, isn't it? We've all seen the core production pain points. You get massive token costs that just completely blow up your budget, crippling latency, and of course, that dreaded lost-in-the-middle degradation, where the model just completely forgets instructions buried inside a giant prompt. And here's the harsh truth. Just throwing a bigger context window at the problem? Yeah, that simply doesn't fix it. It usually just makes the whole thing more expensive.
We've got to make a massive paradigm shift here. Think back to the 2023 mindset for a second. It was totally model-centric, the whole prompt-in, answer-out era. You wrote a clever system prompt, picked the smartest model you could afford, and kind of just crossed your fingers. But that era is dead. To build useful agents in 2026, you absolutely need a system-centric architecture. Production-grade agents succeed or fail based on 3 distinct engineered disciplines that sit completely above the model itself.
Here is our roadmap for this explainer. We'll be covering the end of model-centric AI, context, memory, the harness, and finally, bring it all together into this system-centric architecture.
All right, part 1, the end of model-centric AI.
Relying on a clever system prompt or a giant context window is just a fundamentally flawed strategy today. Why? Well, because modern agents are actually doing real work. They read files, they call APIs, they browse the web, write code, recover from failures, and manage state over sessions that can literally last for hours. Real-world operations create way too much information and complexity to just jam into a raw context window. You simply cannot trust raw model behavior without serious scaffolding built around it.
Moving on to part 2, context, curating the now. If we use a standard software analogy, context is basically your system's RAM. Context engineering is the deliberate design of the absolute minimum highest signal information an LLM sees for a single inference call. It answers one vital question: what does the model need right now to do the next step correctly? Teams constantly overfeed their models. They give them too many docs, too many tools. By deliberately curating the active working set, you completely avoid that recency bias and mid-context neglect.
So what does that actually look like in practice? It's a 4-part context assembly pipeline that flows into a single inference call. First, you've got instructions, your goals and constraints. Second is retrieval, the active documents or logs. Third, memory surfaced, and this is crucial, only the persistent facts relevant to this exact moment. And fourth, tools, the function schemas available just for this specific step. The frontier has really shifted from raw token capacity to the intelligent allocation of attention.
Okay, part 3, memory, persisting over time.
We really need to draw a hard, definitive boundary here. Conflating memory and context is a massive anti-pattern. Memory engineering is not just dumping vectors into a database or pasting a raw chat history into a prompt. No, it is a strict write, manage, read loop. It decides what actually deserves persistence, how to represent it, when to update it, and how to recall it. Remember, it's an external system constrained by cost, latency, and reliability.
Notice how production memory requires a tiered architecture, kind of like a computer's hard drive. You have working memory in the context window, super fast but very expensive. Then short-term session memory. Below that is long-term memory for persistent facts, often using graph structures to handle contradictory facts over time. That has medium latency but a very low token cost. And finally, procedural memory for code and instructions. You are constantly making trade-offs between access speed, durability, and scale. Since it's an external system, it needs explicit state transitions. You have add for new facts, update to maintain a single source of truth, and delete to remove stale state. But honestly, the most important operation might actually be noop, intentionally doing nothing. Mature memory systems do not write everything down. They use noop to prevent noise and long-term state pollution. Because if every single interaction becomes permanent state, your agent just ends up accumulating contradictions and totally runaway costs.
To put some hard numbers to this, think about the number 7,000. Leveraging the quantitative signals we're seeing in 2026, Memory frameworks like Mem0 are hitting high 90s benchmark scores on complex multi-hop reasoning using roughly 7,000 tokens per query. How is that possible? By relying on structured, multi-scope memory instead of massive, bloated context windows. Smart memory selection drastically reduces your pre-fill costs.
All right, part 4. Harness governing the system.
If context is the RAM and memory is the hard drive, then the harness is your overarching operating system. I love this analogy. A powerful model without a harness is like a brilliant new hire with no manager. No runbook, no permissions model, no test suite, no quality gate. Sure, it might do impressive things occasionally, but it won't do them safely or repeatedly. Harness engineering is about creating that exact scaffolding that lets agents execute reliably at scale.
And if you want hard data on why this matters to engineering leaders, consider an internal OpenAI beta from 2026. They generated roughly 1 million lines of code with 0 manually written source code, resulting in 1,500 merged PRs. They achieved this by relying heavily on structural rules, observability hooks, and iterative feedback loops. The takeaway here is undeniable. Agent productivity is deeply harness sensitive.
Academics have actually formalized this into the CAR model, CAR, which cleanly separates policy from capability. First is control, deciding which instructions are authoritative and how conflicts are resolved. Second is agency, what actions the agent is actually permitted to take, how it plans, and task sequencing. And third is runtime, the execution environment, which includes tools, state handoffs, and error handling. This completely separates the raw model from the boundaries it operates within.
Which brings us to part 5, the system-centric architecture. Let's bring the whole shebang together to construct the absolute cleanest way to think about a serious agent stack, built from the bottom up. At the base, layer 1 is the model layer, providing base reasoning. Above that, layer 2, the context layer, curating the active working set. Layer 3 is the memory layer, handling persistent state and artifact pointers. And sitting right on top is layer 4, the harness layer, governing execution policies, retries, and evaluation loops. Memory feeds context, and harness governs both.
Now that we see the target architecture, we've got to talk about the anti-patterns engineering leaders absolutely must avoid. Treating the context window as a massive database is a huge one. It just explodes your costs. Calling naked vector search memory without update rules, that's just approximate recall. Confusing better models with better systems completely ignores that most failures are actually harness failures. Writing memory too aggressively pollutes your state. And finally, skipping evaluation loops in long-running agents makes them incredibly brittle. You need multi-agent harnesses that separate creation from judgment.
Look, if you take away just one single thing from this entire explainer today, make it this overarching, system-centric philosophy. Context chooses what matters right now. Memory preserves what matters over time. And the harness ensures production behavior.
Which leaves us with a critical question for every engineering leader tuning in today. Take a hard look at your own agentic stack. Are you still relying on a 2023 mega prompt? Or have you actually engineered the context, the memory, and the harness? Basically, is your AI architecture truly built for production, or is it just a clever demo? Think about that as you plan your next sprint. Thanks for joining me on this explainer, and I'll catch you on the next one.